Okay, so the question is saying that the pressure P of an ideal gas in a sealed container is given by this formula, right? So where rho is the density and C is the speed of the gas molecules, right? So the question now says further that if the percentage uncertainty in the mean square speed is 0.6%, what is the percentage uncertainty in P? So I made a correction here. P standing for what? The percentage uncertainty P, and P standing for the pressure, right? The pressure given by this formula. Take note of this. Density is a constant, so therefore it has no uncertainty. And the question is telling us that the uncertainty in the mean square speed is 0.6%. Therefore, this is the mean square speed. Or it can be expressed like this: the root of c squared is the mean square speed, right? So the uncertainty in the mean square speed is 0.6%, and density rho has no uncertainty. So therefore, the uncertainty in P, which is the pressure, is going to be equal to the uncertainty in the mean square speed, which is 0.6%. So therefore, your correct answer will be C, right? 0.6%. Okay, so question 2 is saying that a ball is dropped from a tall building and is allowed to fall freely. Which graph shows how the acceleration A varies with time t? Okay, so the y-axis is A, which is for acceleration, and along the x-axis is t, which stands for time, right? So we know that the acceleration at free fall doesn't change. Gravitational acceleration is always constant, right? So therefore, our answer is going to be C. Our answer is going to be C, since we can observe that at C, the acceleration is constant throughout the motion, throughout the time t, right? So acceleration is going to be constant throughout time t. So the answer for question 2 is going to be C. Okay, so let's move on to question 3. Question 3 is a tricky question, so pay very close attention. Okay, so a train is traveling at speed 30 meters per second along a straight path. A person who is in the train walks along the passage towards the rear of the train, which means the person was moving towards the back of the train. Right? Relative to the train, what is the body's speed relative to the earth, right? So if a person is at the back of a bus or the back of a train and start moving towards the front, right? The speed at which that person moves plus the speed of the bus or train, that's the actual speed of the person relative to the bus or the train. So when the person is at the front now, right? This person was at the front, right? And he started moving at 2 meters per second towards the back. So when the person is moving towards the back, his speed minus the speed of the train is the actual speed of the person relative to the speed of the train. So therefore, this person was moving at 2 meters per second towards the rear of the train, and the train was moving at 30 meters per second. So 30 minus 2, which is 28 meters per second, is the speed of the person relative to the train, right? So therefore, the answer of the question will be B, right? So let's move on to question 4. So question 4 is saying that a tennis ball of mass 45 grams was struck by a racket. It moved off with a velocity of 12 meters per second. It then hit a surface and rebounded as in the diagram, right? So we're seeing that in the diagram, we're saying that this is the tennis ball moving with a velocity of 12 meters per second, and it struck a wall, then it rebounds as shown in this diagram. So the question is now saying that if it was in contact with the surface for 15 milliseconds, right, what is the force exerted by the surface on the ball, right? So the ball is striking the wall and it is in contact with the surface just for 15 milliseconds and it rebounds. So what is the force exerted on the ball by the surface, right? So let me show you how you calculate this. Okay, so assuming that this is the positive direction and this is the negative direction, right? So we know that momentum is equal to mass times velocity, right? So therefore, the initial velocity is 12 meters per second and the mass is 45 grams. So 45 grams is just the same as 0.045 kgs and what? Times the velocity, which is 12 meters per second. So therefore, the initial momentum here is going to be equal to what? The initial momentum is going to be equal to 0.54. That's the initial momentum. So I want you to get something here. So we've said that this is the positive direction and this is the negative direction. So therefore, assuming that this ball rebounds with the same speed. So therefore, which means it's going to rebound with the same momentum but in the opposite direction. So therefore, the final momentum is going to be equal to negative 0.54 again, right? Are you seeing this? So therefore, the impulse or change in momentum is going to be equal to 0.108. So this is the change in momentum. Therefore, but the question wants the force exerted by the wall on the ball, right? So for the moment we have the change in momentum, which is 0.1, which is 0.108, right? So the change in we are now using this equation now. The change in momentum is equal to the force times the change in time. So therefore, 0.108 is going to be equal to the force times the change in time. The change in time, the question told us the surface was in contact with the ball for 15 milliseconds. So 15 milliseconds is the same as 0.015. Therefore, if we make f the subject of the formula, f is now going to be equal to 0.108 divided by the time the ball was in contact with the surface, which is 0.015 seconds. 15 milliseconds is the same as 0.015 seconds. So if you punch this into your calculator, you get that the force F is equal to 72. F is going to be equal to 72 newtons, right? Force is measured in newtons. So therefore, our answer is going to be D. Okay, so we are moving on to question 5. Question 5 is a bit stained with the mark I'm using because it was at the back of question 3, right? At the back there is question 3. So this is question 5. Question 5 is saying that which graph shows a particle that has attained terminal velocity, right? So, all right, let me tell you something. So when a body attains terminal velocity, it stops accelerating, right? So it will start moving with constant velocity. So graph D is showing a body that is on its way to attaining terminal velocity, right? But it hasn't reached yet, right? And B now is showing a body at terminal velocity. So a body at terminal velocity, it is the body at terminal velocity is constant velocity with time t. So the velocity doesn't change with time t. So B is our correct answer. B is our correct, as we can see that V is constant over time, right? So let's move on to question 6. So question 6 is a bit stained again, but I hope you can see it clearly. So question 6 is saying that during the launch of a rocket, it produces propellant gases at the rate of 1000 kg per second, so that a speed of 45 kilometers per second is attained, right? The question is now saying that what is the thrust of the rocket at that speed? Okay, so let me show you how you calculate this. So when you're calculating this question, you use this equation, right? So thrust is equal to the velocity times dm over dt, right? So thrust is equal to the velocity times the change in mass over change in time. So we can see that from the question, the change in mass over change in time is 1000 kg per second, right? That's the change in mass over change in time, right? And the velocity is 45 kilometers per second, right? So 45 kilometers per second is equal to 45,000 meters per second, right? This is equal. So thrust is equal to velocity times change in mass over change in time. So therefore, our thrust is just going to be equal to, what's the velocity? The velocity is 45,000 meters per second times what? Times change in mass over change in time. Change in mass over change in time, according to the question, is 1000 kg per second. So times 1000 here. So therefore, our solution, if you punch this into your calculator, you end up with 45 million 45 million newtons. 45 million newtons. So therefore, 45 million newtons is just equal to 4.5 times 10 to the power 7. Right? 4.5 times 10 to the power 7 newtons. That's your answer. So therefore, your answer is D, 45 times 10 to the power 7 newtons. So let's move on to number 7. Okay, we're moving on to number 7. Work done is equal to force times distance moved. So we know that energy is equal to force times distance moved by the force, right? So this is equal to energy, right? So when it comes to gravitational force now, gravitational force is equal to mg, right? So we know that force F is equal to mass times acceleration, right? Force is equal to mass times acceleration. But when it comes to gravitational force now, A becomes G. So we know that gravitational force is equal to mg. So therefore, we know that energy is equal to mg times d. According to the first equation, we are now here, right? So d is for distance, all right? So according to the question, the distance is the height, right? The height h. So the stone was thrown vertically upwards with height h. So therefore, the equation now, equation E now is now going to be equal to mg times h, right? So we know that so at this point now, the gravitational potential energy is equal to the mass times the gravitational acceleration times h, times h here, the height moved, right? So the question now, let's get back to the question. The question is asking which graph shows the variation of gravitational potential energy E with height h. So from this equation, we know that E is equal to mg times h. Right? Is that clear? Right? So we know that from the equation, we are seeing that E is directly proportional to h. Right? So therefore, we know that when E increases, h will increase. When h increases, E will increase. So therefore, it's directly proportional. So the correct graph here is going to be graph B. We know that from graph B, we can see that when E is increasing, h is also increasing, because they are directly proportional. It's not this, it's not a curvature, and it's not this. So therefore, if it was A, it would mean that h is inversely proportional to E. But the equation is showing us that E is equal to mgh, directly proportional. So the correct answer is going to be B. Right? So let's move on to question 8. Okay, so number 7 is saying that which graph shows the variation of gravitational potential energy, which is E, with height h for a stone that is thrown vertically upward, right? So you need to understand the formula for gravitational potential energy, all right? So energy, you have to know that energy is equal to work done, right? Energy is equal to work done. So therefore, the energy E will be equal to, what is work done first? Work done is equal to force times. Okay, so in question 8, no calculations are needed. Okay, you just need to be smart to see it. If you're not careful, you can miss it. So the question is saying that a bulb of mass 2m is whirled in a horizontal circle of radius r with a constant angular speed. Okay, so we want to highlight that. Let's highlight that. This is a constant angular speed, right? A constant angular speed of 1/2 omega, right? So the question is now saying that what is the work done by the body in 1 revolution? So I've told you earlier that no calculations are needed. Okay, so question 9 is saying that which of the following is a characteristic of an orbiting geostationary satellite, right? So let's get through the answers. So the answer for A is saying that same acceleration as the Earth, right? Which is false, right? The B question saying that the B answer saying that the same radius of rotation is the Earth, which is also false. And C saying that the same speed is the Earth. This is false also, because we know that the satellite is at a larger radius, right? And it's moving faster, right, than the Earth. So therefore, the correct answer is D, the same period as the Earth, right? So take for example, let's say this is Earth, this is the satellite. It has the same period as its rotation, right? The same period, right? So therefore, when let's say this is point P, when point P ends up here, when point P moves here, the satellite will also be here, right? When point P ends up here, the satellite will also be here, right? So you might think that this is the same speed. This is not the same speed, just the same period. But if you calculate